In this video, we are going to discuss overloading the stream insertion and the stream extraction operators. We'll start with a few observations. In main, I have an integer, int x. I initialize that to 5. Now we can do something like console output x, and then we can do end line as well. Right, so this is going to print out 5. These are the stream insertion operators, because here, for example, it will insert x into the console output stream. If I hover over this, you'll see in the IntelliSense this helper comes up. It shows us std : o stream. And what does that refer to? Well, basically console output as an object. We'll actually have an entire lesson dedicated to streams and how you can set up streams to output data to a file on your computer, for example, for permanent storage. But just to give you a basic idea, a stream is a flow of data. Similar to a stream of water, for example, it flows somewhere and the data can flow to a destination outside of your program, such as to a file on your computer, for example, or to the console, which will simply display it on the console so you can read it. That's useful for debugging. Or that data stream can flow into your program. So your program can now accept data from outside, such as from the keyboard, where you can type characters on the keyboard, right, and that gets accepted and processed somehow by your program. Okay, so that is an input stream. And of course you can also read data from a file, as we'll see in a later lesson. So that is the basic idea of a stream. It is simply a flow of data, either into your program or out of your program. If you remember from our discussion on namespaces, std : is basically a way for us to organize our code, and it means that console output is defined in the standard namespace. Scroll up and you have to include IOStream for input output stream to use, cout, and cin. For simplicity, we do using namespace standard, which will make the standard namespace global, meaning that this function right here will have access to it, main will have access to it, so we can do this right here, so we don't have to prefix console output and endline with std : each time we use it. If I comment this include out right here, then you'll get an error with console output and with endline, because those are basically defined in the IOStream header or in that file and in the namespace standard. So you should be familiar with that at this point. You can also do cin, console input, and this right here is the stream extraction operator because it extracts from the cin stream and then stores that data in the variable to the right, in this case x. Another observation is that these arrows or these operators kind of point in the direction that the data flows. So it flows, outside towards the console output or towards the console. With the console input, this flows towards the x. That's easy for us to understand. Okay, we are going to take the information that we put into the console or type into the console, and we are going to save that in x or assign x to that value that we type in. Build and run this, and I'll type something like 7, and that will print 7 out again. For these demonstrations, we'll be using the entity class again. It would be nice if we could do something like this for our user-defined types. We can simply do console output, the stream insertion operator, and then entity1, and then that can do something similar to this function right here, which will print out the state of the object, so we can see console output and it prints out member. Right. There's something else to remember. This right here you can see is the operator, and then you have the two operands. Right, so this again is infix notation. And you remember when we overloaded operators as member functions, then in that case the left-hand operand was the user-defined object itself, and then the right-hand operand you would pass in as an argument to that function. But with the stream insertion and extraction operators, the streams are the left-hand operands, right? And the user-defined type will be on the right-hand side. And just finally here, just to show you again that cout is an object, so you can do cout.operator and then maybe pass in some value such as 55. Alright. Cout is an object of type oStream. I'll actually just undo here. If I hover over cin, you can see that is an object of type iStream, so input stream. And we'll have to remember this later on when we overload the stream insertion and extraction operators, because those are going to have formal parameters iStream, which of course is going to accept an object of type iStream, right? So we can pass in cin to that overloaded operator because it's going to accept that as an object. Then also for cout here, we will want to pass in cout as an argument. So the type of that formal parameter is going to have to be oStream. Another observation is that we can chain these operations. That includes the stream extraction operator and the stream insertion operator. And from all of these observations, you can start to think what the header is going to look like for the overloaded function. And also based on our previous example. So here, for example, we're going to have to return a reference to the cout or the cin so that we can chain those or do multiple operations in a single statement, very similar to what we've done previously with the assignment operator. But again, we cannot return this because this is not going to be a member function, this is going to be a friend function. So we're going to have to return a reference, and we want the left-hand operand to be the stream, so cin or console output as I explained. Based on these observations, it should be clear that we are going to return a reference to cout or cin, depending on whichever one it is that you overload. Okay, I'll clean this up here. We'll look at a quick slide and a summary, and then we'll come back and we'll see how we can overload the stream insertion operator to work with our user-defined types. We'll start with the stream insertion operator. Now a quick note here, when overloading operators as member functions, the left operand is the user-defined type by default, right, if you remember from the previous examples and the previous videos. So what you want to do is you want to overload the stream insertion operator as a friend, in other words a non-member function instead. In this example here you can see if you overload it as a member function, it is expected that the left operand is going to be your user-defined type, such as entity in this example. And using this infix notation you have entity1 on the left, and then the stream insertion operator followed by console output or cout. We as programmers are not used to that, we are used to having the, in this case, cout or cin for console input on the left hand side. So as the left operand, as you can see in the second statement, that is what we are used to. So you do cout, the stream insertion operator, followed by what it is that you want to put out to the stream. Finally, we have an example of a stream insertion operator declaration. You can see again this is specified as a friend. And for the stream insertion operator we have OSStream, so output stream. The function is going to return by reference. You do not want to copy the stream object, you just want to return by reference. The operator keyword, the stream insertion operator, for the first formal parameter we do a reference to OSStream, and then on the right hand side or the right hand operand is going to be what you actually want to put out to the output. In this case, the user-defined type in this example is just entity. That could be some other object such as the vector 2D or something else. Let's go and overload the stream insertion operator so that we can get the statement right here to work. Again, we are using the entity class for this. Okay, this is what the declaration is going to look like. And of course, this is declared as a friend of the entity class now. It's going to return a reference to OStream. The first parameter is going to be OStream as well, so a reference to OStream. I'll just call that output. Now you can call that OS for output stream, or you can call it output stream or whatever you like. For the second operand, it's going to take in our entity, and so that's going to be a reference to an entity constant. And I just call that entity p for entity parameter. You can copy this entire header now to go and define this function. But before I do that, I would like to note another thing, and that is this using namespace standard. As I mentioned, it's not good practice to make things global in your program, and that includes any namespaces, so in this case using namespace standard. Instead of adding those to a global scope, you can add them to the scope of a particular function if you want to do that instead. But of course we are doing it in this way in these examples just to make it easy for us so that we don't have to prefix everything with std::. Now that being said, you may decide to remove this later on, or again it may not be global in your file, so what you want to do instead is you want to prefix this right here with std::, and that's the same for this parameter right here, so std::OStream for output stream. I'll just leave it like that for this example. Now remember, this is not a member function, so I do not have to do the scope resolution. We do not want to do this because it's not a member. Now all we have to do is to do the output, all you have to do is something like this. And now what we can do is we can remove this toString function right here. I'll comment out that namespace standard, and then back in main, you will see we have to do something like this now. And these here are actually fine now. But if I want to do inline, again you'll get a squiggly, so now you can do something like that. And you don't have to do it in this way, I'm just showing you what you can expect to see in other people's code and in more realistic production programs. Okay, entity 1 is constructed right here. Let's set the default initialization here to 5. So when you construct an entity, that member is going to get initialized to 5. Again, cout is an object of type OStream. So this parameter right here is a reference to type OStream. And if you want to chain things, so if you want to chain this operator, then again we are going to return a reference to the console output stream. Let's pull and run this. Then that works fine. Now I'm actually going to remove this inline right here. Alright, within the definition of that stream insertion operator. You can see we can now chain the stream insertion operator. If you build and run, you can see you have 1, 2 endlines. Alright, that was a look at overloading the stream insertion operator. Next, we're going to talk about overloading the stream extraction operator. With regards to the stream extraction operator, you can see that the declaration is going to be similar, but instead of returning a reference to OStream, this is going to return a reference to iStream for input stream. As we've observed in the first subsection, this is going to take in the cin object, so the first parameter is going to be a reference to iStream. Okay, let's go and overload the stream extraction operator. I can simply copy and paste that header. That's much faster than typing out all of these characters and operators. For the stream extraction, the second parameter is not going to be const, so it's not going to be a reference to an entity constant because we are going to change or modify the argument. Alright, so let's go and use that. Okay, build and run, and let's see if this works. I'll enter some value, press enter, and that will display that value again. To make this easier to understand, of course, what you can do is, you can do some output maybe right here that says, please enter some number followed by the enter key, or something like that, but this was just a quick illustration. Alright, I hope you found this lecture useful, and I'll see you next time.